Okay, picture this. You're on a plane, cruising at 35,000 feet. You look out the window and it's nothing but beautiful blue sky. But what you can't see, what nobody can see, is that 100 miles ahead, a massive storm system is brewing. We're talking serious turbulence, heavy rain, the works. So how in the world does your pilot steer clear of a monster they can't even see with their own eyes? Well, the answer is some seriously cool technology. This really is the million-dollar question, isn't it? It's not about dodging the fluffy clouds you can see out your window. It's about spotting the invisible dangers lurking miles and miles down the flight path. And to do that, pilots need a special kind of vision. They use this, weather radar. You can think of this screen as the pilot's crystal ball. It slices right through the air, painting a vivid picture of the weather ahead. It's the tool that makes the invisible suddenly and clearly visible. So let's dive in and see what the pilot's actually looking at. How does this system take invisible radio waves and turn them into a clear, easy-to-read map of a potentially dangerous storm? At its core, weather radar is a super sophisticated detection system. Its main job is to find storms up ahead and, this is the crucial part, show the pilot how nasty they are using a really simple color code. It's like an early warning system that gives them plenty of time to make the safest call. And the language of radar is actually pretty simple. Green means light rain, usually not a big deal. Yellow tells you there's medium rain, something you definitely want to pay attention to. But red is the big one. It means a strong storm, lots of rain, and almost certainly some serious turbulence. For a pilot, red is a giant stop sign in the sky. It's a clear, instant, do not enter sign. Now, this isn't just a passive screen they look at, it's an interactive tool. Let's take a look at how pilots in the cockpit can actually grab the controls and change their view of the weather ahead. And fundamentally, it's surprisingly easy. Step 1 is just to turn the weather display on. It just pops up as an overlay on their main navigation screen. And step 2 is to decide how far ahead they want to look. Are we looking at the next 50 miles, or do we need to see the big picture a few hundred miles out? And here are the actual controls that make it happen. See that WX button? One push and boom, the weather map appears. And this little knob, that's the range control. A simple twist lets the pilot zoom way in for a detailed look or zoom way out to see the entire weather system. It's just simple, elegant design, which is exactly what you want in a high-stakes environment like a cockpit. But here's the thing. Not all radar systems are created equal. For decades, radar was a pretty manual, two-dimensional affair. Then, a complete revolution came along that changed the game. The Honeywell RDR-4000. The huge difference really comes down to just two words, 3D and automatic. See, with the old systems, pilots had to manually tilt the radar dish up and down, piece by piece, trying to build a mental picture of the storm. The RDR-4000, it does all of that work automatically, and it does it in 3 dimensions. And that is just scratching the surface. The RDR-4000 is an absolute powerhouse. It doesn't just see rain. It can detect hidden turbulence and dangerous wind shear. It can map the ground, show you a vertical slice of a storm. It even corrects for the curvature of the Earth. This wasn't just an update. It was a total quantum leap in what we call situational awareness. So how does it actually do it? How does it build this incredible 3-dimensional picture of the weather ahead? Well, this is where the real magic happens. The secret sauce is something called a 3D volumetric buffer. Now, that might sound complicated, but really, it's just a digital memory bank where the radar system stores every last bit of weather data it collects. And this is the perfect way to think about it. The radar is constantly scanning the entire volume of sky ahead, up, down, left, right, the whole shebang. It takes all of that data and pours it into that 3D buffer, building a complete live model of the weather. From that one amazing database, the system can then show the pilot literally any view they could possibly want. And the scale we're talking about here is just immense. Vertically, this buffer stores weather data from the ground all the way up to 60,000 feet. That is way, way above where any commercial airliner flies. It captures the entire storm from top to bottom. And horizontally, it reaches out 300 nautical miles. That's about 345 regular miles. That gives pilots a massive heads up, letting them analyze the weather and plan a new route long before they ever get close to it. Okay, so with all this incredible data packed into that 3D buffer, the RDR-4000 can do a lot more than just look for storms. Let's check out how pilots can slice and dice this information in some really clever ways. So the system has two main modes for looking side to side. First, there's WX, or weather mode. That's what we've been talking about. It's programmed to ignore the ground and only show things like rain and storms. But then you can flip it into GMAP mode. It does the complete opposite. It uses the radar signals bouncing off the ground to paint a detailed map of the terrain below, showing you coastlines, lakes, even cities. It's an incredible navigation tool. And here's what that looks like side by side. On the left, in WX mode, you can see those distinct blobs. Those are storm cells. On the right, in GMAP mode, you see the solid, continuous shapes of the land below. Two completely different, super useful views, all from the exact same radar system. But honestly, this is the real game changer. Because the system holds that full 3D model of the weather, it can show pilots a side view, a vertical profile of a storm. This is huge. For the very first time, they're not just looking down on the weather, they're looking right through it. And that gives them a whole new dimension of choice. Before, the only real option was to fly around a storm. But now, with a vertical view, a pilot can look at a storm and see, hey, the top of that thing is only at 30,000 feet. If they're flying at 35,000, they can confidently and safely just cruise right over it. That saves time, it saves fuel, and it means a much smoother ride for everyone. And at the end of the day, that's what this is all about. This kind of technology gives pilots a level of situational awareness that was just science fiction a generation ago. It helps them make smarter, safer, and more efficient decisions, which means a better and, most importantly, a safer flight for every single one of us on board. Systems like the RDR-4000 are just an incredible example of how constant innovation keeps making our skies safer. It really makes you wonder, right? As our skies get even more crowded and weather patterns get more extreme, what's going to be the next breakthrough that completely redefines how we fly?